Hey, welcome to Class 8. So, in this lecture, we're going to talk about scripting and bash scripts in particular. Pretty simple concept, but really powerful. So, we've been talking about bash. We know how to use various bash commands. So, for example, we can say, what directory am I in? pwd shows us our current directory. What's the date and time? We can use the date command. Who's logged into the system? We can say who. And maybe we want to do those three things a lot for some reason. We're bored, we want to know what directory we're in, the date, and who's logged in. We can put those commands in a file. So I can make a file called, you know, I don't know, I'll just call it, data. And in here I can put those three commands. I can say print my working directory, show me the current date, and show me who's logged in. And so if you've done DOS, this is like a batch file in DOS, right? By typing the name of this file, which is data, it will execute these three commands. All right. Well, if I try to do that, it doesn't quite work right away. It says permission denied. If you look at your directory listing and you do an ls-l, these first three symbols up here in the front, this R, W, and dash, those are the permissions for what I can do with this file. The R says I can read, the W says I can write, the dash says I cannot execute. Alright, so we need to talk about permission bits. Each file has 3 bits associated with it. This is read, this is write, and this is execute. And a file has 3 sets of these. This is for the owner. This is for what's called the group. And this is called the world. So everybody who is not an owner and not in your group. So back to the ls-l, Macias, that's my username. That's who I logged in as. That's the owner of the file. Students is the group name. So most students are in this group called students. And I can set permissions that allow other people in this group, i.e. other students, to do certain things, but people from other groups would not be able to. So right now, as the owner, I can read, I can write, I cannot execute. So to set this permission on a file, we think of each of these as a 3-bit number. So read and write are turned on, execute is a 0. The group has no permissions, the world has no permissions. Turn this into an octal number, and it looks like 600. If I want to give myself execute permission, what I should do is turn on that execute bit, 111, and I could leave these as all zeros. As an octal number, that's 700. So I'm going to use the command change mode 700 and the name of the file. So let's try that. I'll say change mode 700 data, and now if I do an ls-l, I've turned on execute permission. So that's a useful command to have, and maybe I want to give other people, other groups, and the world permission to read the file and execute it, but not modify it. So I would want to use a mask like this, read, execute, but not modify. As an octal number, that's a 7, a 5, and a 5, so I could say change mode 755 data. And if I do that, and then I do an ls, I can see the group members have read and execute permission, but not write. And the world has read and execute permission, but not write. If I want to give everybody all permissions, I should make all of these ones. That would be a 7, a 7, and a 7. So I could say change mode 777 data. And if I do an ls-l, everybody has full permission. If I change mode 0, what am I doing? I'm putting zeros in each of these bits. Nobody's going to have any permission to do anything with the file. And now if I try to edit the file, I don't have permission. If I try to VI the file, right, I don't have permission to open it up, and if I try to write it, I don't have permission because it's read only. But I can change the permissions back for myself, so I could change this to 755 data. So I can read, write, execute the file, and just for fun, I'm letting anybody else read and execute it. Alright, so now if I say data, it executes the commands inside that file. This was the print working directory command, this was the date, and this was who. And if I run this again, I get a slightly different date 10 seconds later. And if more people had logged in, then we'd see more people here and so on. So this is a pretty straightforward notion, right? These are just a bunch of bash commands, and we can put them in a file and execute them by just typing the name of the file. So that's the beginning of scripting. But we can do a lot more. We can actually use scripts as a whole programming environment, and we can create programs just like we do in C or Python or Java or anything else. Before we go any further, though, let me talk about comments. So we can always have a number sign, and anything following that is ignored. That's how we begin a comment. In C, it's 2 slashes. In bash, it's a number sign. So see what dir we are in. And I can also, put this on the same line, show date and time. And I can have something at the end saying, script is done. And I could put something in the very beginning. Demo of a simple bash script, njm, fall 2023. And you can have blank lines, and blank lines are ignored. And so all of this works exactly the same way as the old script. All right, so what's happening here? We've said that, when we're sitting at this bash prompt, if I type something like, ls, bash doesn't know what ls means. When it sees this string ls being typed in, it will look in a series of directories for a file named ls. And remember, it looks in the directory specified by this path variable. And eventually inside user bin, it finds this file called ls, and so it executes it. Data is the same way, right? When I say data, it doesn't know what that command means. It's going to check all of these directories. And remember, it eventually checks our current directory for a dot, and it finds a file called data. So it's going to execute this. But this is not executable code. It's not binary ones and zeros that it can just hand to the CPU. It's a script that has to be interpreted. So how is it going to do that? Because there are a lot of different shells. There's bash, there's the Bourne shell, there's Z shell, C shell, T shell. There's all these different shells. So it's useful to tell our current shell how should it execute this program. So the very first line of your file, you can put in what's called a shebang. And a shebang is the path of the program you want used to execute this script. So if I say which bash, bash is a program sitting under /user/bin/bash. So in the very beginning, if I say $!/user_bin_bash, when I just say data, what the shell will do is execute this program and feed it all of this stuff. Right? Now this is just a comment. I can put anything I want after a number sign and it's completely ignored. But if my first line of the file is a $!! it takes the rest of this as the program that I'm asking to run. And it's got to be the very first line. If I make it the second line, it's no longer a shebang, it's just a comment. But if it's the very first line and it has this exclamation mark after the number, then this is the program that's executed when I type the name of the file, in this case, just the name data. So we're always going to want to put that shebang in the beginning so that if somebody's using a different shell and we're writing stuff that's meant for bash, this stuff will get executed by bash. Otherwise, it just uses whatever your current shell is to execute those statements. Alright, so if we want to do something more than just run a series of commands, we can start interacting with the user inside our script. So let me get rid of this stuff in the beginning. And we know about the echo statement. So I could make my script say hello Nick, and now if I say data it says hello Nick. But I could also do something like say echo what is the day today. And if I want to get input from the user, I can use the command read. And so I could say read, response, and then I could say happy. And response is going to be a variable. So if I say $response, it will replace this with the value of the variable, which will be what it read when I said read response. So if I run this script and it says, what is the day today? I can say Sunday, and it says happy Sunday. And if it says, what is the day today? And I say it's balloon day, it says happy balloon day, even though I misspelled balloon. All right, so we can get input from the user, and we can use that input in generating output or in other things that we want to do. So we could say, you know, are you happy or sad? And we could say read mood, and then we could say $mood, $response. So it says, what is the day today? And I can say, you know, day before school starts. And are you happy or sad? And I can say sad, and it'll say sad day before school starts. So we can play around with this however we like, or if we don't want to give the user a choice here, we could just say, you know, mood equals happy, and, you know, do variable assignments like we've done before. And now when I run this, it says, what's the day today? It's Sunday, and it just says happy Sunday. And if I wanted to change that mood to something else, I could change it here in my code. So these are just variables, right? We can assign them values with an equal sign, but we can also input a value from the user by saying read. Now if we look at the manual page for read, we don't actually find what we're looking for. We get something that says read from a file descriptor. This is the description of a C function. And you can see from this little 2 in parentheses here, this is coming from chapter 2 of the manual. And chapter 2 is for low-level system functions. If you do a man on the manual page, you can see a synopsis of what the different chapters are. Chapter 2 is a system call. Chapter 1 is for executable programs or shell commands. So we would like to see a chapter 1 description of the read command. So if I say man1 read, says no manual entry for read in section 1. So if you're not finding something in the manual page, your next option is to type the name of the command or keyword and say -- help. And that's another way sometimes to get help on a command. And in this case, I get a couple of pages of information about the keyword read. Read reads a single line from standard input or from a file descriptor. If no name is specified, the line read is stored in the reply variable. And we can do different things. For example, we can say read -p and put in a prompt, and it will print out the prompt without a new line at the end, and then let us type something in and save that in the value of whatever variable we specify. So you can look at the built-in documentation on these commands and expand their usability. And so that's just an example of reading input and then generating output. All right, let me mention a cautionary tale here. Suppose that I have a script and I decide to name it test, which is not an unreasonable name. And, you know, test does this thing. It reads a description of the day and then says happy day. And if I try to run that, it doesn't seem to work. And I can make all kinds of changes to this script, and I can check the permission bits, and it's set to be executable. But every time I try to run the script, it does not work. And the problem is that test is also, it's a built-in the system. It means something else. And so when I say test, it's not actually executing my script. It's executing some built-in command. But if I say /test, I'm actually telling it what directory to look in for this file, and that's absolutely going to take me to the script that I just wrote. So that's an important thing to keep in mind. If you use descriptive names for your scripts, you're probably okay. But if you're running your script and it doesn't seem to be doing anything, double check and make sure that that you're actually executing the script by trying /. And if that's the case, then your name is conflicting with something else. So give it a different name, something that might be more descriptive. All right, next thing to look at is how we can pass arguments to a script. Because remember, there's two ways we can give information to a program or a script that we want it to process. One is to do runtime inputs. That's what a read statement would would look like. So the script is already running and it's waiting for us to type something in. But we can also use command line arguments. So let me make a new script. I'll just call it stuff, and I'll put my shebang in the beginning. And what I want to do is I want to just type my name on the command line while I'm specifying the name of the script, and then I wanted to use that information that I gave it somewhere inside the script. So the mechanism for this is to just use a variable like $1, $2, $3, and these are like argv bracket 1, argv bracket 2 in a C program, but a little easier to use. $1 is just whatever the first argument is in our command line. So let me just do something like this. Let me say echo first argument is $1, and I'm just going to do a few of these and print out what the first few arguments are. Now remember, if I say stuff, it's going to say permission denied. So how do I change that permission? Change mode, and we can go back to our model here, but we're pretty much just going to be able to stick with 755 if we're not worried about other people seeing our file, or 700 if we want to be kind of secretive and only let ourselves see our file. And if you're developing code for a programming assignment or something, you probably want to stick with 700 so that somebody else doesn't take part of your code. So I'll make this executable with a permission of 700, and you can see stuff has read, write, execute for me. And now if I say stuff, this is a test. It tells me first argument is test. Well, my prompts are a little weirder. Second argument is, a, and test, and so on. So if I run this script now, it tells me, my first argument was this, followed by is test, and the argument after test is blank because I didn't have a fifth argument. That's not an error, that's not a problem. If I just say stuff without any arguments, it'll show me each of my arguments is blank. If I say stuff and I say this is a longer test with typos and extra things, right? It tells me first argument is this, is a longer test. It just picks off those first 5 arguments. So we can use this $ number notation to get the nth argument by just using $number. And we can also say, how many arguments were passed to us. And we can get that by just saying $number. So $number means how many arguments. So if I say stuff, it says $number was equal to 0. And if I say ABC, it says number of arguments is 3. And there I typed 8 arguments after the keyword, and it told me the number of arguments is 8. So $number is a useful command. We can also get to all of the arguments by saying $asterisk. And $asterisk means a long string of all the arguments stuck together one after the other. So if I say stuff, this is a longer test with many args. Arguments are, and $asterisk is equal to this thing. Alright, another thing that's useful is the keyword shift. And what shift says is basically take all of your arguments and move them down one spot. Whatever the second argument was, change $1 to be that second argument, change $2 to be the third argument, and so on. So it basically takes, the whole line of arguments you used, and it throws away the first one and moves everything down one spot. So if I execute the shift command, and then I say after shift arguments are, and I print out $asterisk again, I'll see something different. So when I say stuff, this is a longer test with many arguments. First it says arguments are, and it looks like this. After the shift statement, my arguments look like this. They begin with the word is, a longer test. And at this point, if I looked at $1, it would be the word is. So sometimes that's a useful way to pull off your arguments one after another, is just read the first argument and then say shift, read the first argument, say shift, and so on. And you can do that until there's no more arguments left. And $number will also change when we do that. So I can say let's print out the number of arguments with $number before and after the shift statement. So initially, number of arguments is 8, and then after I said shift, number of arguments is 7. So that can be a useful way to work through a set of command line arguments. And as with C, we can mix and match. We can do some things where we read arguments off the command line, but also we might read some arguments as runtime inputs by using a statement like read while the script is executing. Alright, next thing to think about is arithmetic, because we want to move up to working with loops, and looping kind of requires, incrementing a variable sometimes. So let's look at arithmetic, and we've made this observation before, that if I say echo 1 plus 1, it doesn't give me 2, it gives me 1 plus sign 1. But if we want to evaluate arithmetic, it's pretty easy to do. Just say $paren and put your expression inside there, and now it actually evaluates 1 plus 1. And if I do something like x equals 3, y equals 5, and I say echo $x plus $y, it prints out 3 plus 5. But if I say echo $paren $x plus $y, that actually evaluates 3 plus 5, gives me 8. So we can do arithmetic. So let's make a script called math. And let's try the following. Let me initialize x to 1, and then let me say x equals x plus 1, and echo $x. And let me do this several times. And what should happen is, x starts off at 1. This should change x to 2. This should change it to 3. This should change it to 4. This should change it to 5, and so on. So if I do that and I run math, it shows me 2, 3, 4, 5, 6, 7. So we can increment variables by just saying, variable equals $paren, variable plus 1. And if I had done instead something like times 2, and I do that in succession, then I get powers of 2 coming out. So this $paren is a useful way to say I want to actually do arithmetic on an expression. And the syntax is just $paren, your expression, and then 2 closing parens. Alright, so let me make an important comment here with bash. Spacing is important. When I say $paren, there's no spaces in those 3 characters. There's no spaces between the parentheses at the end. I can have spaces before and after, that's totally fine. But remember, if I try to do something like, x equals $paren 1 plus 1, it's not going to know what I'm talking about. Right? I have to make sure that there's no spaces on either side of the equal sign in order for this to work. So we're going to start talking about a couple of statements, if statements and while loops in bash. And the spacing is going to be super duper critical here. So we've got to look at the spacing that we're using in examples and stick with that. All right, and we'll get lots of practice on that in the practice problems. So let me continue our math script. And let's do the following. let's make a loop that will print out the numbers from 1 through 10 without having to write 10 sets of statements. So let me start off with x equals 1, and I'm going to make a while statement. And so the syntax for a while statement is the following: while space bracket bracket space some condition space bracket bracket space new line do body of the while loop and then the keyword done. This doesn't have to be indented, but you should indent it. It's just a coding style thing. So space, 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 no other spaces. And we'll do some examples in the practice problems where we leave out these spaces, and sometimes it works, sometimes it doesn't. So you want to get in the habit of always having these spaces here and not having spaces, for example, in between the two brackets. And our conditions take one of two forms. If we want to compare two strings, we can say, S1 equals S2. Or we could have S1 equals quote something. Or we could have quote something equals S2. Or we could have, a variable equals var2 or equals some other explicit string or whatever, right? These can be anything, but equal is for comparing strings. And exclamation mark equal is asking, are these two strings different? Equal is asking, are these strings the same? So similar syntax to what we do in C. But that's only for strings. For numbers, we can use one of the following 6 symbols: -GT, -LT, -GE, -LE, -EQ, -NE. This is greater than, less than, greater equal, less equal, equal, and not equal. And we can only use these. We're not allowed to use these symbols. You may find that Bash will accept this. It won't give you a syntax error, but it may not do what you actually mean for it to do. So if you're comparing numbers, use these symbols. If you're comparing strings, use these symbols. And don't confuse the two. Alright, so with that in mind, let's make a while loop that will loop 10 times. So we're going to start off with x equals 1, and we're going to say while bracket bracket $x is less than or equal to 10, do echo $x, x equals $x plus 1, done. Alright, so there's the script. Start out with x equal 1, and while it's less than or equal to 10, print out the value of x and then add 1 to it. And this should loop a total of 10 times. The last time it will loop through is when x is 10. It'll print out a 10, increment x to 11, and then it will kick out of the loop. So if we do that and we run our script, there's our numbers 1 through 10. And if we want, we can say echo -n, which will echo without a new line at the end. And we can add a space to the end of our output. And then if we run this, we get our numbers appearing on one line. We also have this kind of annoying thing where at the end of our program we don't get a new line and our prompt is sitting in the middle of our screen now. So we could clean that up by, after our do loop, just print a final new line, and I can just say echo and not echo anything, but that'll still print out a new line. And now if I say math, there's my numbers 1 through 10. And if I change this to 100, right, I can print out the numbers 1 through 100. So that's a basic while loop. So while loops are useful in programming, right? They're one of the 3 constructs we need for a programming language. We need sequential execution of statements, we need conditionals, which are ifs, and we need loops. So there's an example of a loop. Let's do a conditional. So the way we write a conditional or an if statement in Bash is by using the keyword if, space, bracket, bracket, space, some condition, space, bracket, bracket, new line, then body of the if statement, and then we end with the word phi, which is if spelled backwards. And the conditions are the same. We can use, dash GT, dash EQ for comparing numbers. We can use double equal, exclamation equal for comparing strings. So let's put an if statement in here. So we're going to echo $n $x. Let's print something special when we're halfway through our list. So question, did we reach 50? If bracket bracket $x equals 50, then echo halfway there phi. Alright, so I've just added an extra statement in the middle of our loop, which will check to see if our variable x is equal to 50. And if it is, it will say, hey, we're halfway through our output. And so when I run that, it prints 1 through 50, says halfway there, and then continues with 51. So just a simple example of an if statement. So that's how conditionals work. And we can use this in lots of different ways. So let's make a password script. So we can say enter password, and we can read our password, and then we can say if bracket $password equals baseball, then welcome back, because it recognizes us because we know the secret password. We can also say else and put in an else statement. And so we could say else echo, we'll just say wrong password. Goodbye. And we could say exit to get out of the script, and then there's the phi. And if we don't exit, we can say you are now authorized. All right, so what does this look like? We're going to read a password from the user. If the password is a secret password, baseball, we'll say welcome back, and then we'll say you are now authorized. If the password is wrong, we'll say wrong password, goodbye, and we'll exit from the script. So change the permission to make the file executable, because this is a new file. And when I run pw, enter password, well, if I put in a bad password, I get a syntax error. All right, so how do we debug this? It tells me line 17, unexpected end of file. So let's look at our script. Let's do a 15G to look around line 17. And it's unhappy with this line, but the error that I was getting said looking for matching quotation mark, unexpected end of file. So it got to the end of our file at line 17 down here, and it said, hey, you didn't have a closing quotation mark. Well, I do have a pair of quotation marks here, but there must be something earlier in the code where I'm missing a quotation mark, and if I look back, it's right here. So technically this echo statement said echo quote wrong password echo, and then I have a new quoted string starting right here and ending there, and then this is beginning a new quoted string, and it doesn't find a matching one. So the sentiment of the statement was correct, but the details were wrong. So I'm missing a quotation mark here, so let me put that in, and let me say password, and if I put in a bad password, it says wrong password, goodbye. If I put in the correct password, it says welcome back, you are now authorized. And I could put in something like an else if bracket bracket $password, let me put it in quotes, equals secret, then excellent, you know the super secret password. Else. So here's an example of an if then else, if then else. If password's baseball, then do this. Else, if password is secret, do this. Else, do all of that. So now I've got two passwords, a regular one and a super secret one. So password, put in a bogus password. Same thing, unexpected line. End of file, but we know what to look for now, right? Go down to line 20, well, there's nothing wrong with that, but there's a missing end quote somewhere, and you just kind of have to look back and try to find it. And I can say question mark quote to look for quotation marks, and every time I find one, I should find a matching one. So the passwords are fine. Syntax error, unexpected end of file. So the other thing this can mean is that you're in the middle of something like an if statement or a while statement, or something where it's expecting more to your script, and instead your script just ended. So you have to go back and dig into the syntax. If password, then this thing, else if. And so here's a funny thing about Bash. If you want to do an else if, there's a special keyword for it. And the keyword is just ELIF. And it's got to be one word without a space. Right? I don't know why it's set up like that, but it's just the way the language specification is written. So ELIF is the correct way to do an else if. And so now if I say PW, bad password, says wrong password. Normal password, it says welcome back. And super secret password, it says excellent, you know the super secret password. And you can do all the things that you do in your normal programming language, right? So for example, I could say down here, auth level equals 1. If you get the super secret password, I could say auth level equals 2. And in my statement down here, I can say you are now authorized at level, and I can print out what authorization level you have. Regular password gets you level 1, super secret password gets you level 2, and then I could use this variable's value elsewhere in the script to control whether or not you're allowed to do certain things. So if I say baseball, it says you're authorized at level 1. If I say secret, it says you're authorized at level 2. And if I put in a bad password, it doesn't even get to that statement because it kicks me out early. So those are if statements, right? And ifs and whiles give us the two main constructs we use for building up more complex scripts. All right, we can also do for loops in Bash, but I'm not going to teach for loops. The reason being it's a fundamentally different syntax from if statements and while loops, and I want to stick with ifs and whiles because they are consistent with one another. And if you can make a while loop, you can always make a for loop. There's a different kind of for loop where we can say loop over a set of things inside a space separated list, and it's like a for in statement in Python. We'll talk about that later. But for doing basic flow control, if you want to iterate a fixed number of times, you can do it with a while loop, and I encourage you to explore that and do what we did in our earlier example where we printed a message 10 times, right? 10 numbers. So a couple of other variables in Bash that I want to mention to you. One is called $random, and $random just prints out a random number. And it'll be a number between 0 and 32767. And that's a handy way to get a hold of a random number. The other variable that's useful to know is $question mark. And $question mark tells you the return from whatever the previous command was that you executed. So if I say date, and then I look at $question mark, I get a 0. If I type something meaningless, and then I look at $question mark, I get something non-zero. And that usually means there was an error in your previous command. And if I look at $question mark now, I get a 0 because my previous command was an echo statement, and echo worked fine. So this is a useful way to get a hold of the value that your previous command returned. And if you write a main program and you say return 7, you'll see that 7 after your program finishes if you say echo $? So for example, if I make a main.c and this time I say instead of a void main, it's an int main, and I say return 7, compile that. Right now, $? is a 0 because my compile command finished fine. If I execute main and then I look at $? It's a 7 because that's the return value from the command main. If I look at $? again, it's a 0 because that's the return value from echo. And if I put something in here that it doesn't like and I recompile and I get some errors and now I look at $? It's non-zero. When GCC returns a 1, that tells me something went wrong. Alright, so that's a little bit about initial comments on bash scripting. Ways to make a file executable by setting the permission bits and putting the shebang in the top to make sure the lines are executed with bash, and then using what we already know, echoes and variable assignments and so on, but also using $paren to do arithmetic, which we'll work more with later, and doing if statements and while loops.